So we were talking about the declaration. So once you declare your array, so then you can, maybe you can on the same time you can initialize as well if you want to initialize it. So I have given one example over here int number. Okay, if you are initializing, then you don't need to give the size of that particular array. It is just optional. So the all the element would be inserting. So if you talk about the data, how it is going, so it is starting from index 0 and up to the size -1. So if suppose that I have integer of 5, so my index will start from 0 to 4. So if I want to get the value from number index of 0, so I can write number in square bracket 0. So I will get, like in this example, I will get 20. That is stored in the 0 index. If I want to get the last element of it, so I can use the number in square bracket 4. So I will get 60. So type of array. So basically there are two type of array. Single dimension array. Okay, we have only one dimension array. Those are stored in row wise only. So they are just values only. Those are storing in the in continuous memory. If you talk about multi-dimension array, so if we talk about two dimension, for example, this. So there are two two row and there are three column for it. So in first row we have 0 1 2, and second row we have 4 5 6. So if you want to fetch the data of, like for example 4, so I need to mention like it, since it is 0 and 1, and so I need to mention number 1, and in the second square block I will mention 0 over here. So I can fetch value of 4 over here. So in this type of array, we generally use to iterate two for loops. So at least we need two for loop to get the value for the each element. And you can see the size. So basically it is 2 and 3. So we can multiply by 2 and 3, then we will get 6. So it can hold up to 6 element in this array. Now we talk about structure. Structure is a user defined data type, okay, that allowed combine data itself, like items for different kind of data type. Like we can have integer, character, doubles all together, but unlike array just holding the similar data type or at the continuous memory location. But here we can have the different data type all together. So how we will declare a structure? So we have one struct keyword, and then we can programmer can provide a name for that particular structure. Then they can write as much as they want all the member variable over here. Like you can see, I have taken one example. I have written int a, character c, and double d. So if you see the size of this, so if I see integer is 4 byte, character is 1 byte, and the double is 8 bytes. So total, if I add all these bytes, so it is 13. But basically these are not 13 because there are structural padding which are added because of Bell memory management. So we need to align the memory. So what happens? So if I see integer is taking 4 bytes, then character is taking 1 byte only. Then over here, compiler will add 3 more bits. Those we call structural padding. Okay, so that is being used during the in the structure only to get the better memory access once we run the program. So compiler will do that for us. So now in that case, the size is 16, 4, 4, and 8. So it will make it 16. Okay, so we can initialize the structure when we can declare it. Okay, and we can declare it only. So if you want to declare any structure, so we have struct keyword, then structure name, and then we can create a structure variable. Like I have created struct underscore var. So and I can initialize with the variable if I want. Okay, so I can mention all the values. Okay, so suppose that I have taken one example. If I want to access any variable, okay, so any member of this particular structure. So I can use this variable name and dot operator I can use, and I can access the element through that. So dot a is equal to, I am accessing the a element of that particular structure. So here I am assigning to the 10 to that particular value. Similar way, I can assign to some other value that I other variable as well, if I want. So it is just an example. Union is also a special user-defined data type that allowed storing different data type in the same memory location. That is the main difference between structure and union. So how we will declare the structure? We use union keyword and we give the name to that particular union data type, and then we declare all the elements or all the variables to that particular union. Like I have declared here integer a, character C, and double D. So if I want to see the size of this type of variable, this union type of variable, so integer is 4 byte, character is 1 byte, double is 8 byte. So it will take the maximum of them, since we are just sharing the memory of all these. So the size of this union variable would be 8 byte. So if I want to initialize, I can initialize the similar way as I initialize in the structure. Like I can use union keyword, okay, and union name and union what I have created over here, okay, and I can assign any value to that particular member of this particular union data type. So if I want to access the value, suppose that for example I have assigned union var dot a. Dot a, that is a is integer and c is character. So 10 is allocating only lower 1 byte only, since although a is having 4 byte, but 10 will go into the lower byte of it. It is a little Indian. So c also would be having the 10 10 value only, because it is also pointing to the same memory location. If we want to get the value of the float, so float is going in some other manner in a memory. That so there is one sign bit, and there is exponent bit and significant bit. So the way the float value is extracted from the memory, it is different. So the value would be quite low in that case. Now we talk about string. So string is a sequence of the characters that terminates with a null character, that is backward slash 0. Okay, that is a special character over here, and so that is being used in the string where we want to terminate it. For example, I have taken the example. I have declared a character array. That is the array. Okay, so where at each index I'm keeping one character of it. So basically these are 12 character over here, but the size if I see, it would be a 13, because there is one more character, that is the null character, though that is not showing over here. So through that it is terminating. And if I see this second example, char star c, so that is the pointer. So that pointer is pointing to that types string, c type string. Okay, that is the constant string. You cannot modify it. If you try to modify this string, so you will get the segmentation fault. And if but here in the first example, you can modify the string, since it is allocating the memory in this array, so that you can modify it. So that is the basic difference between these two type of string. Now we talk about enumerator. So enumerator is also like a user-defined data type in C. It is mainly used for to assign the named like a name of for any kind of integral values. For example, I have any case like I have weeks. Though there these are 7 weeks only. Sorry, 7 days only in that particular week. So I can assign a I can create a numerator. So if you want to declare a numerator, so you can create like enum, and you can create one value name like we created for a structure, similar way here, and then we will give all the name. So constant 1, constant 2, so it will start from like it is like 0 1 2 3 like that. So instead of writing 0 1 2 3, I am assigning some name over here. So those names are recognized by this enum. And so you can create the variable as well. So this is the declaration. Through the declaration, you can, through that flag, you can create a variable anytime. For example, I have taken this months example. So we have 12 months from Jan to Dec. Okay, so I have created 12 enumerated for it, like 12 value it is having. So if I create the variable like month from that, so I can assign to Jan. So Jan is known to this enum. But if I try to assign 13, okay, so that it will not work, because 13 is out of this range, like it is starting from 0 to 12. So if I assign 0, then it will work. And if I assign 12, then also it will work. But 13, it will not work. We will get compilation error. Now we talk about compilation stages and execution of C program. So once you write a C program, so you create .c file and .header files. Okay, and so once you start compilation, so very first stage is pre-processor stage. In that you will include all the header file which are defined, which are given in .c file. Okay, those are included and those are replaced over there in that unit in .i file. And there are macro. If you create any kind of macro is nothing but you are having any kind of constant, so you just give the name through the hash define. So those value would be those name would be replaced by the value that we have assigned through hash define. And we can remove the comment in the state. Conditional compilation also happen, like we have some certain condition. Based on that condition, we are including the code and excluding the code. So uh, those things would be taken care in this pre-processor time. Then once it is done, then we process through the translator. So here we convert to dot s file, that is the assembly file. So here we check all the compilation like issues and all. If there any kind of syntax issue or there is some compilation error over here, so those things will be directed over here. And if we talk about assembler, it is just converting to the assembly code to machine code. That is a .o file or .object file would be created. Suppose that I have 10 .c file, so 10 o or 10 object dot file would be created in that stage. Once you finish this stage, so you will go to linking linker stage. So in there, you are combining those all files into one file, that is exe or a binary file, where we are including the dynamic library reference as well. And if there is we have executed like we have compiled with the dynamic library, so we can have the reference. If we are compiling with the static library, so we can have all the definition of those functions. Those are there in that particular executable file. Then size of the executable file would be greater than the dynamic library executable file. So once you executable the executable file, then we load on the RAM, or that is the main memory. So loader will do that. So once we click, suppose that we click on any kind of executable file or like exe in Windows, so it loader will execute this and it will load to the main memory. That is the primary memory. It is also that is the RAM memory that we have. Now we talk about memory layout and storage classes. So storage classes are the four type of classes, so which also give the information about the variable that is created. Suppose that if we have auto storage class, so if we create any local variable, those will go to the auto storage. So it will going to stack section of the main memory. And the initial value, if we don't define the value to that particular variable, so value would be garbage value. The scope would be the within the block where it is declared, and the life would be the end of the blocks. Once this block is finished, so it will go off. And if it is the external variable, like we have the data block. Okay, here you could see the data block over here, so it will be going to that particular section. And if we are initializing by 0, if we don't define any value to that. So it will go into BSS. We just declare it. If we define with some value, so then that value will be given to that. And the scope would be the global multiple file. So we can declare that particular variable in one .c file, and then that particular variable can be shared or accessible with some other .c file as well. And the life of this type of variable would be the entire program life when it is executing. It would be there. If we talk about static, it is also similar to the data, but there is a difference between scope. So scope is within the file where it is declared, and if it declare any kind of function or any kind of block, so it is related to, restricted to that particular block. And the life would be to the entire life of program. So but the accessibility depend upon the block where it is declared. If we talk about register, so these are the register. Once we create any register variable, so it is going to store in the CPU registers. So although these are those are not enough for registers, so it depends upon compiler with whether it will treat as a register variable or not. So but it would, if it is a register variable, so it will be much faster than other variable. We can perform we can get the better performance than other storage classes. So other part of it is would be the same as auto, like initial value would be garbage if it is not defined. Scope would be within the block. Life would be in end of the block. Now we talk about the once you load any program, so there are this like basically four segment of the memory, like stack, heap, and data, and text. So data is divided between two. Like in the text, first we talk about text. So text is the all the instruction set that we are performing in the program. Those are going to the text. So this is the read only segment of the main memory that we cannot access, and like we cannot modify over here. And if the data is initialized, so it will go to the initialized data section. If the any global variable is there, so those are initialized, those will go in initialized data. And if it is not initialized, it will go into the BSS section of the main memory. And if we are using any dynamic memory allocation using malloc and calloc, so those data, those memory block will be taken care from the heap. So in the heap, those blocks are assigned to the pointer which to be are allocating the memory. The stack. So when we do the function calls and everything, so everything is done by the stack. So all the local variable also getting stored, like auto variable is getting stored in the stack only. Now we talk about the small case study about the small unit of any kind of C program. So basically, once you write a C program, you are including all the header file, okay, and you are declaring macro and all the preprocessed directives. So those are known as the preprocessed directives. Those start from the hash. Uh, then you have the global declaration. So out of the any function, the area is known as global declaration or at the top. So if you talk about this uninitialized integer variable, so since it is not initialized with any value, so it will go to the BS data section of BSS. And then if we talk about the second integer variable that is initialized and with 10 value, so it will go to the data section since it is already initialized. And if we talk about a static variable, so this static initialized variable will be getting stored in data section, but it is not accessible out of this file. Now we talk about the local variable. So I have created a local variable like int global, sorry, local variable over here. So there we are assigning the garbage value. Since we are not, the compiler is assigning the garbage value for that, since it is not initialized with the any value. But the second, the local initialized integer variable, it is having the 5 value. So there will be the 5 value, not a garbage value. If we talk about static, the here we are not initializing, so it will go to the BSS, but accessibility within that particular block, that is main function. It is initialized, so it will go to the data section. And if we talk about the block, so apart from the function, there are, you can create a block through uh, this kind of block. Like you can create like block scope. I have created over here. So that is that particular in curly braces. So it is the block. So the scope of this block scope variable within that particular block only. If I want to print using this printf, so I'll get the compilation issue over here. And if I am creating the static variable as well, so in that case also I will get the compilation error if I try to exit it out of this particular block. So that's how it is restricted to that particular block that is in curly braces over here. So that is all about how we are allocating the memory for the global, local, static variable, how those are initialized and where those are storing in the main memory. Now we talk about a key application where C programming is being used. I have mentioned over here, like as we had talked about in our early slides as well. So basically, this C programming is used in embedded systems, system application, desktop application, and database as well, operating system compiler development, IoT application. So basically, we need the very safety critical application, and suppose that if we need the better performance and efficient memory utilization, and and better portability and the or faster execution. So there we use C programming. So if you talk about database development, also we use C programming over there, and the operating system as well. So these are the key applications where we are using C programming. Now we talk about key industries. So these industries are aerospace and defense, automotive, railway, medical and healthcare, industrial automation, IoT. These are very safety critical applications. So those are basically developed in mostly in C programming only. So these are the key industries. But apart from there are other industries also there. But there C programming is not using very much. Uh, yes, so I'm done over here. Thank you for listening me.